Hello, today we're going to talk about elements. So, any element placed in a flame will change its color. Atoms are made of positively charged nuclei and negatively charged electrons. Left on their own, the electrons of an atom tend to relax to the lowest possible energy, which is its grounded state. Quantum mechanics constrains them to appear in various distinct patterns called orbitals. Putting atoms into a flame, though, adds energy to the looser electrons and pushes them into other orbitals. They release the energy they stored up as particles of light and drop back to where they ought to be. The color of light a chemical burns depends on the energies of the photons, which are determined by the energy it takes to move electrons from one orbit to another. Colors are distinctive to each chemical, so the color that is emitted depends on which element is placed into the flame. So, now that we understand that, let's apply this information to our plane. FPV has shown us the halo system, which we now know hosts and displays all of our luminaries. The technologies below are creating elements that project upwards to move about the halo light show we see. The mechanism that FPV has decoded and Jimbo has animated will show the underworld and the workings of this technology. What I'd like to show you is the beauty that is in what we see as it creates the elements. It creates them, it heats them, and they rise to our surface. Through this beauty, we see the alchemy of creation happening. The effects are all over the world, and as we may find them beautiful, do we know why they appear as they do? Well, let's take a look and see some of these places and what they show us about our underworld happenings. We have lakes and caves all over the plane that emit the alchemetic colors of the element being heated. It's just like the flame test, but on a very large scale. We find an array of blues and greens, yellows and reds, but what are they creating? We know that these areas definitely go along with our real world data, so that right there can tell us that something is going on below. Each color in the lakes and caves shows us which elements are being created. Again, they are heated and they rise to the surface, and then they are what we see. This is found everywhere, from autumn leaf colors, now they make fireplace colors, all the way to the fireworks that America sets off every 4th of July. The next chart I'm showing is giving us a good idea of what the dominant element would be in our colorful subjects. Using this data now, let's look at a few specific areas and how the light coloring tells me which element the angel is producing. The first color we'll talk about is green. It represents silicon and carbon. We have a green lake in Lithuania, Vilnius, as well as a neon green lake on the North Island of New Zealand. We also have a very pretty one running through this cave in Indonesia. Next, we'll talk about black, which is aluminum. Here, I found, which I really didn't know if I would find a black lake or not, that we have a black lake in the Rocky Mountains. I find it very interesting to learn all this stuff. Next, we'll take a look at red, and that's for our elements iron and phosphorus. I managed to find this very bright red lake in Texas. We also have cave systems and land that show red, such as this Antelope Canyon. We have a red tinted one in Cypress, or you could consider it pink. So I'd say that it has iron and calcium here in Cypress. There's also a pink lake in Western Australia, which I was pretty taken aback by. Pink is for calcium, by the way. There's also this Petra cave system, and it shows an abundance of reds and pinks. Next is purple, which is potassium. I did find one real photo of a purple lake, which I'll show here, but when I went to the page to find the origin, all the writing was of some kind of Middle Eastern. I could not read it, and I was not able to obtain where the photo was taken at. Next, we'll look at yellow. The dominant elements are nitrogen and argon. And I found an example in Chaku Strait on Kisham Island. I hope I pronounced that right. As well as the St. Michael's Cave has a lot of yellow coloring to the walls. Finally, we'll just take a look at our blues, which contain magnesium, chlorine, and hydrogen. A lot of these are found in Austria, Colorado, Oregon, and Australia, just to show a few. We also have several cave systems that emit a beautiful shades of blue. So the point was to show all the beauty, since most of the stuff we normally present is very much on the technical side of the world. And that's about it. Have a good day.